Okay, here's the problem. We have this function x minus 3 divided by x plus 1. It's a nice little rational function. Find the inverse function domains and ranges for both functions. Okay, so first look at this one. So what is the domain of f? Well, we do division here, and we don't want to divide by 0, so we know that x plus 1 cannot be 0, so x cannot be -1. So we have all real numbers except -1. What is the range of this function? Well, it's like, I don't know, because we don't have a method to find that what values does this function actually produce. But we will say that the inverse function, well, it will tell us, because the domain of the inverse is the range of this function, and the range of the inverse is the domain of that one. So there is this nice relationship. So let's leave the range for now. So the inverse function is basically just the idea that if I produce y from x using this formula, then, well, I just want to reverse this relationship. Instead of producing y, I want to, given y, I want to go back to x. So there is a simple way to figure this one out. So the simplest trick is the following: we swap x and y. So I write down x equals y minus 3 divided by y plus 1. So why did we do it this way? Well, because we sort of got used to the idea that y is the function of x. So that would be no problem. I mean, you could just go like this and express x as a function of y, but this is nicer. It's sort of less likely that we make mistakes. Okay, so how to do this one? Well, this would be x times y plus 1 equals y minus 3. So now I have x times y plus x equals y minus 3. And what we want to do, we want to just express y as the function of x. Okay, so I have to get all the terms that have y in it. So it's x times y minus y. Here I have minus x minus 3. Okay, so I can just extract y. So that would be x minus 1. Okay, so y is just minus x minus 3 divided by x minus 1. Okay, so it's like that's the inverse, but how can I check? So is this really the inverse? Well, you know, if f of x is x minus 3 times x plus 1, and f inverse of x is minus x minus 3 divided by x minus 1. So then I can easily check, because if I compose f with f inverse, then I should get just e of x, which is just the identity function x. And same thing, f inverse composed with f should give exactly the same. So this is how we can check that. So let's do that. So this is actually the more complicated part, or it requires more calculation. So let's do f after f inverse first. And what's the definition of this? Is function composition. So this would be the f of f inverse of x. Okay, it's a good idea to take your time and write this down. It's the definition, just like this is what function composition means. And not jumping over steps. So what is the f inverse of x? So that's minus x minus 3 divided by x minus 1. Okay, and that is, now this gets sort of more interesting. So I have to take all this and put it into x. So I use some parentheses just to show that what's happening here. Okay, so now this is just an exercise in dealing with these rational expressions, and that's sort of elementary algebra here, because I need to find the common denominator at the top. So let's just cut this into 2. So this would be minus x minus 3 minus 3 times x minus 1. Okay, that is divided by x minus 1. And here minus x minus 3 plus x minus 3 minus 1. Okay, so I can, well, simplify by this part. That makes it easier. And now I have minus x minus 3 minus 3 times x plus 3 divided by minus x minus 3 plus x minus 1. Okay, so things start to fall out here. So I have it's negative 4 times x divided by negative 4, and yeah, we expect something like this, because it's gonna be just x here. If you don't get x, that means that well, there are several possibilities. One possibility is that you made some mistake here. Okay, and it's really the inverse, it's just there was a mistake here. However, it's also possible that this function is not the inverse. So if something went wrong in this computation, when you find the inverse, and this is not really the inverse, then yeah, you don't get x here. Okay, so if you don't get x, well, you need to figure out what went wrong, because yeah, for these very simple rational functions, it's sort of easy to find and guaranteed to have the inverse. Of course, you have to do f inverse after f, which will be just the f inverse of f of x. Okay, this should be x as well. Okay, I skipped over this calculation here, but you have to do it. Okay, you have to do this part as well, and it should be somewhat similar calculation. Okay, so now we can, if we establish that this is really the inverse, then we can look at it like, okay, so the f inverse of minus x minus 3 divided by x minus 1 is a function. Again, it's like I have to look, well, what's the domain of f inverse, and that's, sorry, that's nothing there. That will be, well, to cut it short, well, let's don't cut it short because we are not in a hurry. So x minus 1 cannot be 0, x cannot be 1. So we have all real numbers except 1. So now what do we know? Well, if that's the domain of the inverse function, so now I know that the range of f will be this, and also know if I check back what was the domain of this function, and that was, yeah, that was all real numbers except -1. So I know that the range of f inverse will be exactly that. So there is this nice relationship. That's the idea. When we turn around the function, while the domain becomes the range and the range becomes the domain. Okay, we are happy with the calculation, but you know, just to see, we can check this whole thing with the computer, with GeoGebra. So I have x minus 3 divided by x plus 1. Okay, this is how it looks like. We know that. Okay, so this is where the function is not defined. Well, sure, it's a vertical asymptote there. This is a rational function. Okay, let's look at the inverse. We calculated its inverse, and that's that one. Okay, well, so let's have this, and maybe not have that. So you see that the green one is just a mirror image, mirroring through this axis of the blue, and the same way, let's see if I have y equals -1. So that is the range of the inverse. As we can see that it's -1 is not in it. Yeah, that's right. That's the blue is the inverse, and it never produces. That's sort of a horizontal asymptote for that. Okay, so we verified everything with the computer. Strictly speaking, this was not necessary because, well, if the algebra comes out and you do the composition of the inverse with itself in both ways, and it comes just the identity function, it comes to x, then yeah, we are right.